Right, welcome everyone. Thanks for tuning in today to this exciting talk on API drift. Well, I don't know if it's exciting or not, but at least it's been quite interesting for us. So we've been building a lot of MCP servers for our clients, and we also tried to study the MCP servers that are out there. I believe we looked at around 200 MCP servers, and we tried to test those servers to understand how they work, and we found some very interesting challenges, and that's what I would like to present today, which is kind of, again, for people who've been in the API space. The API drift is a common problem that we've seen. Now we see the same problem that is coming into the MCP servers as well. So let me quickly jump in, introduce myself, and then we will get started with the topic. So my name is Naresh Jain. I'm the founder and CEO of a company called Specmatic. We've been helping organizations to build high quality AI ready APIs and help them scale it by transforming their API specifications into executable contracts. And as you can see, we support a whole bunch of specifications from OpenAPI to Async API, GraphQL, gRPC, and now MCP as well. So we are a completely no-code solution, which allows both tech and non-tech folks to be able to leverage the tooling. So if you're looking for contract testing, that's we have a very powerful offering on contract testing, on service virtualization, or what people call mocking. Also, something unique that we offer, which has also been we've been able to luckily patent it, is a backward compatibility testing capability. And these have been battle tested at several large organizations. So don't be afraid to try them out. And we are open source at core, so you would see that OpenAPI, MCP, and WSTL are all open sourced, right? So that is Specmatic, and you can find more details about us if you Google for us. Now let's jump into the core topic, and I'm not going to make any assumption that people are very familiar with MCP, so I'm going to spend the next maybe 10-15 seconds just explaining how MCP works, a little bit more technical under the hood, what is going on. So you think about MCP, typically they run inside an MCP host. It could be Claude or Cursor or an agent, whatever is your favorite tool. This interacts with an LLM, and again, you could have any LLM that you might be using. It interacts with an LLM over an API, over HTTPS. Inside an agent, or inside a MCP host, you would have an MCP client which talks to an MCP server, using JSON RPC. So JSON RPC is the protocol that an MCP client would use to talk to an MCP server. The MCP server then would talk to its actual source that it's basically adapting for. In this case, a database, so it would talk over TCP. Similarly, you could have an API, and it could talk over HTTP to that API, right? So this is at a high level, just the top levels architecture, if you will, of MCP server. Now let's double click into what's happening in this JSON RPC so we better understand what's going on. So MCP itself has a schema that is published where you would see a whole list of tools that are, basically a whole list of methods, that, it expects that a server to implement. And some of these are to be called by the server, or some of these are to be called by the client. The server ones are typically like a callback, kind of things. And what we found out of our research is that most MCP servers out there only cover the list of methods that are highlighted in purple, and even in this, a lot of them just focus on the tools part, not so much on prompts and resources. Is something that we found, but that's okay. Let's kind of double click into how the tools, right, because that's really what an LLM is looking for a list of tools so that it can then delegate the task to a tool to execute on its behalf. So when we look at essentially how the tool listing itself works, so typically an MCP client is going to first initiate a connection, and after it initiates the connection, it's going to send a message for a method tools list, which is going to respond back with a array, a list of tools in JSON RPC, of course, but it's going to list, the MCP server is going to respond back with a list of tools. So in this case, we see like a weather tool that has come back. And the good thing is that as part of the response, you'd also see what is the input schema that the weather tool requires, and what is an output schema. Of course, the output schema is optional, and but the input schema is mandatory, right? So this is how the client knows, okay, if I were to make a call on weather, I need to send this kind of JSON object to the weather tool to be able to get a valid response back. So you would notice that in this case, in this specific case, it says that there are two properties, city and country, that you can send. You can find out a weather for a given city within a country. And in this case, the city is mandatory, which is what is highlighted here as required, and country is optional. Okay, so that's kind of the input schema, and this is how MCP defines it. Now let's look at actually invoking an MCP tool itself, right? So you would make the method call tool/call, and here you're giving the name of the tool, which is weather in this case, and then the arguments that it required. So we're passing city London and country UK, right? And you would get a response back which basically says, okay, the temperature right now is 21.4 degrees, and the unit in which I'm representing this is Celsius, right? So that's how the MCP server is going to respond back. Now you might ask, okay, this is great, this is a happy path scenario. What happens if I send a malformed request to the MCP server? How does it handle that? Right? Great. So let's look at one example on that. So I'm making here a tools call, and remember we said that city is mandatory, country is optional, but for some reason I'm only passing the country and I'm not passing the city. So what do we expect to happen? Of course, right? You guessed it. So you would expect a error response to come back, and since this is JSON RPC, the response code will be some strange looking numbers. It's not what a lot of people are familiar with in terms of HTTP statuses, where you would expect a 400 response bad, like a bad request response, right? In this case, you would get a response with a message saying, this mandatory argument city is missing. And so that is kind of how bad requests are handled in MCP server, right? So this just helps you understand how the communication between the MCP client and an MCP server works, and what kinds of things the MCP server is supposed to handle, right? So now with that, let's kind of quickly jump in and look at a live demo of how did we go about testing a whole bunch of MCP servers, and what did we learn from that. So let me quickly switch my screen and go to the demo. So let's come here. Actually, let me come here. All right. So I'm going to start with something called. So we started our testing with something called the MCP Inspector. It's a open source tool available by. It's open source and available. So all you need to do is just simply run this npx command. And I'm going to run the npx command. It's going to try and bring me up MCP server. And in this case, we'll be testing the Postman's MCP server that is out there. This is, again, I'm not trying to call out on anybody. I'm just trying to use something that most people hopefully will be familiar with in this space, and test that. So I'm testing the MCP server on this thing. I've set the authentication mechanisms already. So let us try and connect. Okay, great. So we were able to initialize and we were able to connect. So once you've connected, what you can do is you can list all the tools that this MCP server exposes. So as you can see, I can create a collection, I can create an environment, I can create a mock, a spec, and so forth, right? So let's pick this create workspace, for example, right? So this create workspace is for us to be able to create a new workspace in Postman. And let me scroll down. It also gives you a little bit of a form, which are the parameters that is expected to be sent, right? So in this case, I'm going to, let's say, create a workspace called Naresh demo, and let's say this is of type public, and I'm going to give description as for now, just some dummy text. And let's run this tool. Okay, so once we run this tool, great, we see that we've got a success. We've got an ID of the workspace and the name that we gave it, and so this tool call was successful, right? Now this is great. Now, but if I was supposed to be testing this setup, then as you can imagine, there were like a whole list of tools that we saw, and then even within each tool there is a whole variation of options, right? So for example, I might want to now test what happens if I send this with a private as a thing, right? So I might want to change this and say private, and then click on the run tool and make sure this works fine. I might want to select some other things. And so what I'm trying to highlight is that you would have to repeat this for multiple tools, and for each tool multiple combinations of inputs, right, to be sure that your MCP server is at least functionally working, right? We're not even talking about performance or security at this point. We're just saying functionally, does this work or not, right? But this very soon will result in a combinatorial explosion, and it will be very manual and tedious, and also error prone to kind of repeat this every time you evolve your MCP server, or anytime someone makes a change. So this certainly didn't seem like a right approach moving forward. This is great for exploratory and playing around, but if I'm really interested in testing my MCP server to make sure it is working as expected, and when I've made a change there's no regression, then this is not a great choice. So we looked around, we couldn't find anything, and so this is where we decided to build an open source tool ourselves called MCP Autotest in Specmatic. So I'm going to quickly show you a demonstration of how you can do this. Again, we'll just use the Postman collection. What you will see is I'm going to run a Docker command, and I'm going to be executing this against the Specmatic's open source MCP, and I'm just going to say MCP test. And I'm just giving some default values over here. So let's quickly run this and see what happens. So this is going to start making certain calls to MCP, establishing the connection, initializing the connection, and then getting the list of tools from it, and then take each tool, pick up the input schema from those tools, and then generate a whole bunch of tests for us to make sure that the MCP server is working. Now notice I have not written a single line of code. Like I said earlier, Specmatic is a no-code solution. All I had is just a Docker command to execute this, or if you fancy a UI, then we also have a UI from which you can do this. But typically you would want to run this as part of your CI process to make sure, as part of the CI, all these checks are running every time. And so as we speak, without any, configuration or tooling or any of that stuff, we are able to basically go ahead and execute this. And it also brings up a report. So this is interesting. Let me quickly go back here, and what you will see is a summary of 33 tools that we have tested as part of this. If I scrolled all the way through the top, you would see what has happened here is we've initialized a connection with the MCP server. After initializing the connection, we have fetched the tool list, and this has given us a huge list of all the tools that are available with their schema. And once we have got that, then Specmatic will then take these tools and construct JSON RPC requests, where we are calling these tools, and we go through and exercise different tools. and then we assert whether the response that came back was a valid response or not, and accordingly we will say whether the test passed or failed. And finally it's going to publish the summary for us, and also give us a visual report, right? So you can see here 33 tests ran. Out of the 33 tests, 27 passed and 6 failed. Okay, that is interesting. So 6 tests have failed. Why have the 6 tests failed? Also, you would see that these are all only positive tests. In a minute I will show you how to generate negative tests or resiliency tests as well. But even in the happy path tests we do see some failures, so let's try and understand what these failures are. So on the get collection tool, we've got a failure. It says invalid parameter, and the error is the limit parameter provided is invalid. Value must be a positive integer smaller than 100. Okay, so parameter should have been less than 100, but Specmatic for some reason has sent a number greater than 100. Let's look at what was the request that Specmatic sent. So Specmatic sent this workspace. It sent a name, and then it sent a limit 696. Okay, that is interesting. So it sent a limit 696. So what was the input schema that we got from when we made the initial tool list call, right? So this is the schema that was returned, and here is the limit. And as you can see in the limit, it says it's type integer. Description says maximum number of rows to be returned in response, right? There is no mention here of limit being 100, right? This error that we are seeing. So this clearly seems like a drift between the MCP, what it is telling us, and the underlying API itself that the MCP server is talking to. There seems to be some kind of a drift, and there is no communication about the limit being mentioned here. So this can really throw an LLM off, and you might be burning unnecessary tokens trying to resolve this, when ideally this should have been, there are built-in in JSON schema, there are built-in mechanisms to say that, hey, this is the limit, or this is the range in which these values should be present. Okay, so that's fine. Let's look at some other errors here. So it says, okay, the path parameter / file path is invalid. Okay, so it looks like we have sent a file path according to us, but this says that this is a bad request or a malform request. So okay, what happened here? Specmatic sent a file path as this, and when I look at the file path, it simply says it's a string. There are no constraints defined, or typically the way we would express this is we would have a regex which would define like a file path regex, which will allow us to send that. So again, here there is a potential, the LLM would also trip on things like this, because it really doesn't know that you're expecting a file path. Now you might say, hey, there is a description, and the LLM would read the description and figure this out. Well, sometimes it may not. This may still not be very descriptive. So it's better to actually give a regular expression which to express things like this, right? That's very common. Let's look at a few other failures here. We see some kind of a timeout. That is okay. Let's look at this. Parameter is missing in the request. So the parameter collection is missing in the request. So we called update mock, and what did we send to update mock? So we sent all of these parameters. We did not send collection as a parameter here. Why didn't Specmatic send collection as a parameter? Let's look at the properties. So I see name, environment, description, private, version tag, and a config. I don't see anywhere in the spec a parameter called collection, which is exactly why Specmatic never sent a collection. However, again, this is a classic case of API drift, where the underlying API is expecting a collection, but the MCP is not aware of this. The MCP server is not aware of this. Again, a very classic problem we have seen in many API implementations where the implementation is out of sync with the specification, or in this case, the implementation is out of sync with the MCP server as well. The last one is interesting. So it says, this failed, and basically it's saying only one of content type or name should be provided, and the response is a malformed request. Okay, so what this is saying is that name, type, or content, only one of them should have been there. But Specmatics ended up sending all three. Why did Specmatics send all three? Let's look at this. So this has spec ID, file path, name, type, content, and it says file path and spec ID are mandatory, the others are optional. But nowhere here is it written that only one of them is required. So obviously Specmatic is not aware of it. It sent all three, and this is the same mistake that any consumer of this MCP would make, right? So again, this is a very poorly defined spec, in my opinion. You would expect to use something like one off, which will say, hey, I have these name, type, and content, but only one of them is to be sent, right? And so that becomes explicit and descriptive within the schema itself. So here are just some of the problems that we saw with this particular thing. And again, not trying to call on any one particular implementation. We saw this across many such implementations, and this seemed like quite a worrisome problem, right? Let's do one other interesting thing here. Is I'll quickly demonstrate this capability of resiliency testing. So remember earlier in the demo I showed you where we had to select public and then private and so forth, and you had a combination over there, and it's just going to be too much to test all of that yourself. So what I'm going to do is I'm going to try and turn on resiliency testing and run this only on one particular tool. So right now I'm just going to run this on create workspace. So you will see that Specmatic is now going to go and try and do both positive tests and negative tests. What do I mean by negative test, right? Negative test means that, if the spec says that, for example, property or attribute X, Y, and Z are mandatory, then what it's going to try and do is not send one of the mandatory parameters, maybe only send X and Y and skip Z, and see what happens in this case. Or maybe play around with the data types and see what happens. Are those being gracefully handled by the MCP server and its underlying implementation, or they're going to give you some weird error? Or even worse, are they just going to assume and continue without failing? So you can already see a whole bunch of tests are running, and some of them have passed and some of them have failed. So let's quickly go back here and see what has happened. So notice just on one tool, right, create workspace, Specmatic has generated 77 tests for you, out of which 40 tests have passed and 37 tests have failed. Now we have generated 11 positive tests and 66 negative tests. So this is what again gives you a pretty good way of testing all positive and negative scenarios. And you would see that a bunch of positive scenarios also have failed in this case. So what is this saying? Invalid parameter error. Body.visibility status is invalid. Okay. We have not passed anything called visibility status. Why is visibility status failing? Okay. So if you read this error, the description here in the schema, it says that the type enum, which is type personal, private, public, team, partner, and in the description it says that the type of the workspace, personal or private, are only available on Postman Professional or Enterprise. But that's kind of hidden away, and it's nowhere like explicit in the schema for someone to know, right? So again, this is kind of an error where Specmatic is not aware of this body.visibility. Also, the error message is not very clear because it says body.visibility status is invalid, but we never sent a visibility status. You'd see a few other things like the slug is not unique, which is okay. What else can we see here? Visibility status is invalid. Uh, Here is a negative test. So let's quickly look at what has happened in this negative test. So you'd see that what we've done is workspace type. We have selected personal from this, and we've mutated the workspace name from a string to a number. So the workspace name should have been a string. We have changed that to a number, and we expected that this particular thing to fail, right? Because we're sending an invalid data type. But what ended up happening is it still accepted, the requests happily, which seems like problematic, right? If you're saying that the data type should have been string, even if I send something else, why are you accepting it? You should not be accepting it. So that you'd see quite a few of these negative test failures because of that, where we are sending name as number or boolean or things like that, and we're expecting a failure, but we are still getting a valid response back. In this case, we've selected personal type enum, and we've made description mutated to null, right? So description was sent as null. But if you see in the schema, description is not specified as a nullable, right? It should not be nullable. Otherwise, you have to explicitly define that as type string comma null is allowed. In this case, it's a string, which means the description should always be present. But in spite of sending null, it's still accepting this. So these are the kinds of failures. Again, I don't need to drill on this, but these are the kinds of failures that you would find. And again, in my opinion, if you're a developer and you had access to a tool like this, then as you're developing your MCP server, you would be able to test this thoroughly and make sure it's all working fine before raising even a PR. And even once you raise a PR, typically this would run as part of your CI and make sure all of these tests are passing, and only then go in, right? So to me, this is true shift left of testing an MCP server so that things like this don't leak into production, right? There are different error codes that are wrong and whatnot. So anyway, so that's kind of a quick tour of this. There are similarly examples for Hugging Face and stuff like that. This is again an open source project, so you can go ahead and try this on your own MCP server and see what you find. Curious to know, what do you think? And if you want to join us and help us improve this MCP server, then we are more than happy to welcome PRs and team members to join us. So again, let's do a quick recap. Effectively using JSON schema construct seemed like a common problem that we saw across the board. Not specifying limits, not being explicit about mandatory or optional parameters, something's nullable or not using combination keywords like one-off and things like that. So this is something we saw across most of the MCP servers that we tested, and it seems like a very in my opinion, a fundamental design problem in the specification and the API itself. The second is we saw a lot of people relying on description and not necessarily using the built-in constructs that exist in JSON schema to define their their constraints or things like that, right? This means that you're letting the LLM interpret these, right? And you might have specified in the description saying the number should be between 1 and 10. Now, the LLM can make its own assumptions, whether it's an inclusive range or an exclusive range. And again, do you really want this kind of behavior? Because what might happen is you might test and it may all work fine. But when you at runtime, the LLM might make a slightly different decision, and so you might be caught by surprise, right? So you don't want to leave these things open-ended at runtime, right? You want to be as precise and as explicit as possible. And finally, again, this Specmatic auto test will allow you to run these things as part of your development cycle, shift left, and avoid any kind of API drift between your API and the specification that you have, and now also between your API and your MCP itself, right? So that now we have multiple places where things can go out of sync, and we want to make sure that we can use an automated tool that can catch these kinds of things to avoid this kind of a drift for us. So I think that's pretty much it. Again, like I said, it's open source. Feel free to go try it out, and let me know what is your experience. Always happy to hear from you. So thanks again for watching this video, and have a safe MCP journey. Thank you. Bye.